Hey everyone, welcome back to another video. Today I'm going to be building and reviewing the cheapest Ender 3 style printer I could find on Amazon. I picked this one up for about $160. If you compare that to the Ender 3 V2, which costs $280, there's quite a bit of price difference, but the feature set looks to be almost exactly the same. So let's find out if this cheap Ender 3 V2 alternative is worth your money. Looking inside of this box, it looks almost identical to an Ender 3 V2. After unboxing and inspecting all the parts, everything appears to be clean and in good condition. It looks like they used the exact same stepper sizes for this machine as the Ender 3 V2. One thing I am a little disappointed... Alright, that tempered glass is pretty strong. Anyways, as I was saying, I'm a little disappointed to see that they carried over the Ender 3 V2's poor power supply mounting. Check out the video I did on the Ender 3 V2 power supply if you want to see what I'm talking about in more detail. This printer comes with a decent user manual that shows you exactly how to put everything together. The Z-axis lead screw makes a bit of a grinding noise and it's a little hard to turn, so I'm going to put some grease on it. It looks like this stepper motor isn't perfectly in line with the axis on which this brass nut moves up and down. So as it gets closer to the bottom, it kind of wants to move the lead screw over to the side. To help resolve this issue, I'm going to loosen this mount that the Z-axis motor sits on. By loosening up all four of these nuts on the bottom, that'll allow the stepper motor to move around a little bit. So I'll lower the Z-axis all the way down to the bottom, and then tighten everything back up. So now I'm assembling the top of the gantry, and something that I noticed is everything lines up exceptionally well up here. So that means they did a good job cutting and drilling this aluminum extrusion to make sure all the corners are square and flat and all the holes are in the right spot. Otherwise it probably wouldn't line up this nicely. Although they did cheap out a little bit on these bolts. This is about the fourth or fifth one that I've tried to put the Allen key into, and it didn't fit in just right. It's one of those things where it works just fine, but if you look at this Allen key, it kind of wobbles around in there. Alright, after putting the screen on, tensioning the belts and wheels, and doing a little bit of cable management, we're finished with the build. So in order to hit this low price point, Voxelab had to save money wherever they could. The only two parts of the build that I really noticed that they were trying to save money was on the bolts, and they didn't include a pair of clippers, so you're going to have to provide your own set of clippers if you go with the Voxelab over the Ender 3. In terms of the rest of the fit and finish, this thing's put together pretty well. These extrusions look great and they fit together just perfectly. Overall, I'm pretty impressed with the mechanical build, but let's take a look at the electronics before we start our first print. All the limit switches, cabling, and wire management seems decent, and if we look underneath, everything down here seems pretty similar to the Ender 3. So now I'm going to open up this motherboard compartment and take a look at the PCB that's included. On the left we have a Creality Ender 3 silent motherboard, and on the right we have the Aquila motherboard. So let's compare the two. Both have silent stepper drivers that you can see on the right side, with small heat sinks. We have our power coming in at the top on both boards, and then 3 screw terminal plugs. On the Ender 3, I believe one of these is always on, one controls the heated bed, and one controls the hot end heater cartridge. On the Aquila, I'd expect it to be the same as the Ender 3, but I'm not really sure why there's 3 MOSFETs there. In terms of upgradability and extra ports, on the Ender 3 we have plugs for the X, Y, and Z stop, 2 fans, the bed thermistor, and the extruder thermistor. So there's no dedicated ports for adding a BL touch or a filament runout sensor on this board. If we look over here on the Aquila's main board, we've got 2 extra ports for sensors, and I think we've got one for a BL touch here. So there's a much better upgrade path for the Aquila. In terms of the main board, I think the Aquila's is a little bit better than the Ender 3's, just because it has those extra ports for adding upgrades. So that's another point for the Voxelab Aquila. Alright, so I'm all ready to turn it on and start a test print. One of the quirks that I like about this machine already is that when it's powered off and you move the stepper motors, the hot end will make a little squeaky noise. I like that. Alright, so I'm going to plug it in and we'll see if it smokes or if it prints. So it seems pretty much like an Ender 3 V2 at this point. I'm going to install the included 8GB micro SD card and see if there's any stuff on there that I can print. This micro SD port is pretty nice. The card sticks out about 3mm, so it's really easy to grab it. So let's do the Aquila test model. These icons, I'm pretty sure these are pictures of words, and they have, they're using like JPEGs or something, so you can see little like dots in there. It looks like after you've Xeroxed something about 20 times and you start to see little dots around the words. That's what we have here. So that's a little bit weird. Interesting choice, Aquila. You know, you could have used just regular font and words, but alright. So I'm preheating the PLA, and that'll get everything up to temperature so I can do my bed leveling. Alright, so I had to go around in a circle, leveling at each point about 3 times around before it stabilized, and now it seems like it's pretty well leveled. Also, it looked like there was some filament leaking out of the nozzle while I was doing this, so that means they probably test around the hot end before they shipped it out, which is a nice touch. It's good to know that they're testing these machines before you get them. Alright, and we're off to the races. First print, we'll see how it turns out. Looks like our test print is just about finished, and it's looking pretty good. Ooh, my Z stepper is getting pretty hot though. Oh my gosh, and my Y stepper is 68 degrees. I'm probably going to need to turn those down by adjusting the potentiometers on the motherboard. I'd say this is a pretty successful test print. Yeah, this quality is fantastic. I don't think the Ender 3 V2 can really do any better than this. You can check your stepper driver current settings using a digital multimeter set to the 2V setting. I'll need to touch this positive lead to each of these potentiometers and compare them to the reference values that I have. It looks like I'm getting like 0.92, 0.96, so that should be 7.2, so I'll turn that down. Alright, and my Y steppers are set to 1.14. We're going to need to turn that down to 0.55. So after making that adjustment, all my steppers are cool to the touch. This one's 36 degrees, 30 degrees, so much cooler. I noticed that there's some slight banding issues going on here. And I think that's partially because I turned the reference voltage down for the stepper motors, because I didn't have that artifact on the sample print that I did before I turned those values down. So I'm going to turn up the reference voltage a little bit before I start this next print. And something I didn't mention before is that it's fine for these stepper motors to run over 100 degrees Celsius. So it might have been a case where Voxelab just wanted to turn that up as high as possible to get the best print quality. I think I turned it down too low. Alright, so I just unboxed this Ender 3 V2 and I thought I'd check out the initial quality. So one thing that I noticed is that the bed is kind of stuck in position here, like I'm pushing in it, it doesn't want to move. And this is caused by Creality over-tightening the V-groove wheels. So now we're zoomed in underneath the bed and you can see this wheel kind of locks in at a certain spot. But now I'll just work this back and forth until that flat spot is gone. Another thing you can do to mitigate the issue of the flat spot on the wheel is try to turn one of these wheels 180 degrees relative to the other one, and that'll make it so that the flat spots on the left and right side wheels don't line up. So instead of having one large bump per revolution of the wheel, you get 2 smaller bumps. You can see this bed runs pretty nicely now. There's still a slight bump where that flat spot was. I just didn't want to leave a big bump there because that can affect your print quality for your first couple of prints. If you look at the aluminum extrusions, you'll notice there's some scuffs and dings on there. And if you look at the aluminum extrusion used to build the gantry of the 3D printer, you'll notice that one of these has a different surface finish than the others. So it probably came from a different batch of material. I lined both ends of the extrusion up on the back, and you can see that one of these is sticking out further, which means that the extrusion on the left is ever so slightly longer than the extrusion on the right. So the printer should still run and work fine, but, you know, little quality issues like this give me a little bit of caution about trusting the quality of the rest of the machine. Again, on this Ender 3 V2, it's missing the ventilation holes for the power supply down here. So this metal cover is blocking part of the power supply's ventilation system. The Voxelab Aquila Z-axis limit switch comes pre-installed, while on the Ender 3 V2, I have to install this limit switch myself. I'm happy to see that Creality used higher quality screws than the Voxelab Aquila. You can see all of these screws fit the hex in there nicely, whereas on the Aquila I had some issues where the hex wouldn't fit in so well. The Voxelab Aquila also has a slight design improvement that they implemented on the X-axis holder. If you look on the Ender 3 V2, I have to put 2 small screws in here. You kind of have to do this awkward maneuver where you screw in 2 screws through these tiny holes. So you have to switch from tightening like this to going in like this, and then you have to tighten it one small bit at a time, and it's just kind of awkward. When we look at the Voxelab Aquila, they replaced those 2 small screws with larger screws that are further spaced apart. For this screw, you don't have to do any awkward going through the middle of a small hole in the back in order to tighten and loosen it. You can just access it right there. And for the other screw, you have this relatively large access port that makes it easier to get to compared to the Ender 3 V2. If we look at the Voxelab Aquila's other X-axis support, you can see they use larger screws than on the Ender 3 V2. And this will provide a more sound connection. So I applied some grease to this threaded rod, and it's still making a slight grinding noise. If you look closely at this rag, you can see I'm getting some grime and metal particles off of this threaded rod. So that was probably the issue. I just finished cleaning and re-greasing this threaded rod, and now you can see it runs a little better. You can tell it still grinds a little bit down there, which isn't great. So I'm going to have to knock a point off of Creality for their quality control. This is my 3rd Creality printer that I put together, and it's the first one to have this issue. And to top things off, the screws they provided for the spool holder on the Ender 3 are too long. So this doesn't tighten down like it should, and this will just wobble back and forth as you're printing. So I'm just going to replace these screws with some shorter ones that I have on hand. But, you know, that shouldn't happen either. What's going on, Creality? If we look at the spare nozzles provided by Creality and Voxelab, you'll notice that the Voxelab nozzle on the left is slightly nicer than the Creality nozzle on the right. The fact that Creality would ship nozzles like this, where the orifice is slightly off-center, is a little disappointing. There's also more scuffs and marks on the Creality nozzle. Here's a side view of the nozzles so you can look at the threads. And again, the Creality nozzle is noticeably lower quality. You can see these threads aren't very shiny, they kind of have a rough surface, and the threads on the Voxelab Aquila are nice and shiny. And here's a view of the back of the nozzle, just for completeness. As I'm finishing up assembling this Ender 3 V2, there's a couple final steps that are a little awkward. One is attaching this side piece. You have to kind of reach behind this and get these screws in a kind of an awkward angle. The Voxelab Aquila addressed this by making these screws much more accessible, so this wasn't any trouble at all. Another awkward spot on the Ender 3 V2 is plugging in this X-axis limit switch. You have to like reach your fingers in there, and I don't know, it's just really not easy to get to. It's hard to see in there, and it's hard to get your fingers in there. The Voxelab Aquila addressed this issue by making the X-axis limit switch easy to access, so I can just reach it right here. Plugging it in and unplugging it is no problem at all. The Voxelab Aquila scores another slight win on usability because the SD card reader is mounted flush to the front of the sheet metal, so it's easier to access and grab. If you look at the Ender 3 V2, it's mounted flush to the back of the sheet metal, so you can push it and you got a little bit less to grab onto. On the Ender 3 V2, the filament comes out right next to the threaded rod, which is kind of annoying because it gives you less space to work when you're inserting and removing filament. In the Voxelab Aquila, they space this out a little bit more so that it's easier to get your fingers in there to install and remove filament. And if you have grease on your threaded rod, you don't have to worry about that getting onto your filament. Oh, and one final thing. The Voxelab Aquila came pre-configured to 115 volts, while the Ender 3 V2 came set to 230 volts. I don't know exactly what happens if you plug this in with the wrong setting, but if one of you knows, please leave the answer in the comments below. So after assembling these two 3D printers back to back, what are the takeaways? Well, surprisingly, the Voxelab Aquila takes the win in terms of overall assemblability and quality. The parts that came with the kit were cleaner and more consistent than the Ender 3 V2s. And they made some nice improvements to assemblability, including exposing the plug for the X-axis limit switch, having the Z-axis limit switch pre-installed, exposing the screws for the LCD mount, and having more accessible bolts on the back side of this X-axis gantry. The only area where the Voxelab Aquila could use significant improvement is on the fit and finish of the screws that they provide with their kit. They're a little more difficult to put the Allen heads into, and they don't lock in as securely as you'd expect for a socket head cap screw. Also, there's some black powder left on the table after assembling the Voxelab Aquila, and I think that was just paint that was flaking off of the low quality fasteners. Alright, time to power these machines up and start some test prints. Now, neither of these aren't the quietest printer in the world, but if you want silence, check out some of my other videos that I did on how to replace your fans with silent fans or completely remove fans from the system altogether. But anyways, I'm jumping straight into a challenging print with both of these printers. We're going to put them to the test. This is a print that'll run for over a day, and it's part of a White House model, so this should look pretty cool in the end and really showcase how fine of details these printers can produce. So we'll check back in when these are done and we'll compare them. The Ender 3 V2 is having a little bit of issues putting down the first layer. While the Voxelab has a nearly perfect first layer going down. If we do a quick checkup, we're on about the third or fourth layer, and it looks like the Voxelab Aquila has some spectacular quality going on. These corners are nice and crisp, everything's staying attached to the bed. I noticed this is a slightly rougher bed surface, so things are going to stick to it a little better. If we look back over at the Ender 3 V2, it's got a smoother bed surface. It feels like it's just a thin layer of paint, not like a textured surface. And you can see it's got worse bed adhesion. The corners are peeling up a little bit. I don't think it's enough to cause serious problems at this point, but it's just something I got to keep an eye on. Also, the layers aren't going down as smooth. I think that might be down to the nozzle geometry and the fact that the Aquila's nozzles are more nicely machined than the Ender 3. If we feel this surface, this is perfectly smooth. This is like extremely smooth. If we look back at the Ender 3 V2, you know, there's this rough surface. Not really a fan of that. So checking back on my prints, you can see the Voxelab Aquila is doing a great job. But the Ender 3 ran into some issues. Let's try and figure out what happened here. Alright, now here we can see the filament is coming in from the spool, and it got redirected, so now instead of extruding into the Bowden tube, it's going to the side. If we look at this tangle of filament that's coming out of the Ender 3 V2, you can see the pattern that the gears imprinted onto it. If we look at the broken end of the filament, you can see this got flattened down and eventually it broke, which caused the printer to stop feeding properly. An important setting is how much force you clamp down on the filament with. If the tension is too low, you can skip steps, meaning that you're trying to drive the filament forward, but it doesn't want to go, and you'll end up with under extrusion. The opposite problem is too much tension, which I think is the case here. So I'm going to loosen the screw a little bit. Oh, well, I can't loosen the screw. This is as loose as it gets. Alright, Creality, you're throwing me another curveball. So I'm going to put this in a bench clamp and just clamp down on this to kind of permanently deform the spring to be shorter, and that should help me get lower spring force in this extruder. I'm going to take a look and see if they even bothered to hot tighten the nozzle. So when I turn this, the nozzle shouldn't come loose easily. Oh, and it came loose pretty easily. Alright, so now we got 6 nozzles lined up here. The 3 on the left are some no-name cheapo Amazon brand. The one on the far right is the one that came with the Voxelab Aquila, and then the 2 remaining here are the ones that came on the Ender 3 and the spare nozzle. Let me put this all back together and we'll try another print. So I just had another failed print on the Ender 3 V2. It's a little disappointing, but I'll try it again. Maybe the bed wasn't leveled correctly or something. Meanwhile, the Voxelab Aquila is still printing away on my White House model. One issue I had with the Ender 3 V2 is this pillar was broken while printing. One other area that could use improvement is this layer line you can see here. I'm not sure what caused that. If you know and wouldn't mind telling me, just leave a comment down below. The top surface of this print is pretty nice, but if we compare it to the Aquila's top surface is smoother. I had an issue with these chimney stacks up at the top. They kind of poke up a little bit, so these surfaces aren't flat at the top. But overall, still a very impressive print. Alright, switching over to the Voxelab Aquila White House. Overall, the level of detail looks about the same, but this print has less defects. We're missing that strange layer line that appeared on the other White House, and all of the pillars here are intact. Also, if we look at these chimney stacks on the roof, they're flatter and they don't have the pointed bits up at each corner. So after printing with both of these printers for about 40 hours, here's my takeaways. We'll start with the Ender 3 since that's the incumbent budget 3D printer. Something I noticed about this Ender 3 is that it's pretty picky about the first layer. At the beginning of each printing session, I would level both machines' beds using a sheet of paper to set the correct height for the bed. On virtually every print, after leveling the bed and starting it, the Voxelab would stick its first layer. While on the Ender 3, I'd have to spend an extra 15 to 60 minutes tuning it and trying to get it to stick. And even in the end, I didn't get them all to stick perfectly on the first layer, but I just let it run out. For the Voxelab, its more textured build surface was more forgiving when laying down the first layer. It was easier to get started, and I was more confident that the prints would stay stuck to the build tray. Overall, the part cooling and print quality is very similar to the Ender 3 V2, but I'd give a slight edge to the Voxelab Aquila because the bottom of the benchy was showing less sagging than the ones printed on the Ender 3 V2. One thing that kind of confused me about the Voxelab Aquila is the strangely high VREF voltages on the stepper drivers. So I turned that down and all my prints have been going just fine. One thing I really liked about the Voxelab Aquila is they took the time to make improvements over the Ender 3 V2 instead of just straight up copying it. And most of these improvements revolve around making the assembly process easier. So there's certain parts in the Ender 3 V2 that are just kind of tricky to put together, and almost all of them are addressed on the Voxelab Aquila. Overall, I'd say the build quality of the Voxelab Aquila is nicer than the Ender 3 V2, with the exception of the fasteners that they provided to assemble the kit. It was sometimes difficult to get the Allen wrenches to fit into the hex heads, and this probably just has to do with them using low quality fasteners. So if I had to pick one of these printers to recommend to buy, I would definitely go with the Voxelab Aquila. They took an already successful design and made some improvements on it, and are offering it at a much lower price. But then again, this is just a sample size of one. I've got one Ender 3 V2 here and one Voxelab Aquila. So this comparison might not be representative of what your experiences might be. So if you've had any difficulties with the Ender 3 or the Voxelab Aquila, let me know down in the comments below. If you like this episode, make sure to hit that like button and subscribe to the channel because I'm going to be doing some more upgrades to this Voxelab Aquila. Also, I've got a big lineup of extruders, hot ends, and other 3D printer accessories that I'm going to be reviewing soon. So subscribe to the channel if you want to see those. Alright, thanks for watching and I'll see you next time.